Hadoop has awareness of the topology of the network. This allows it to optimize where it sends the computations to be applied to the data. Placing the work as close as possible to the data it operates on maximizes the bandwidth available for reading the data. In the diagram, the data we wish to apply processing to is block B1, the light blue rectangle on node N1 on rack 1. When deciding which task tracker should receive a map task that reads data from B1, the best option is to choose the task tracker that runs on the same node as the data. If we can't place the computation on the same node, our next best option is to place it on a node in the same rack as the data. The worst case that Hadoop currently supports is when the computation must be done from a node in a different rack than the data. When rack awareness is configured for your cluster, Hadoop will always try to run the task on the task tracker node with the highest bandwidth access to the data. Let us walk through an example of how a file gets written to HDFS. First, the client submits a create request to the name node. The name node checks that the file does not already exist, and the client has permission to write the file. If that succeeds, the name node determines the data node to write the first block to. If the client is running on a data node, it will try to place it there. Otherwise, it chooses the data node at random. By default, data is replicated to two other places in the cluster. A pipeline is built between the three data nodes that make up the pipeline. The second data node is randomly chosen node on a rack other than that of the first replica of the block. This is to increase redundancy. The final replica is placed on a random node within the same rack as the second replica. The data is piped from a second data node to the third. To ensure that the write was successful before continuing, acknowledgement packets are sent back from the third data node to the second, from the second data node to the first, and from the first data node to the client. This process occurs for each of the blocks that make up the file, in this case, the second and the third block. Notice that for every block there is a replica on at least two racks. When the client is done writing to the data node pipeline and has received acknowledgments, it tells the name node that it is complete. The name node will check that the blocks are at least minimally replicated before responding. This concludes this presentation. Thank you for watching.